Good morning. Myself Balamurugan, working as an assistant professor in the Department of Electronics and Communication Engineering at K.S. Rangasamy College of Technology, Tiruchendur. Today, I'm going to discuss the topic was remote sensing process and their radiation principles. This topic under the course of remote sensing. Let me see one by one. Now, what is the definition of remote sensing? What is remote sensing? Remotely collect the information about the data or areas or phenomenon. Remote sensing is the science on art of obtaining the information about an object, area or phenomenon through the analysis of data. From this analysis of data acquired from the data by a device, the device is placed in long distance or away from the earth surface or earth surface features to be measured, that is not in contact with the object, area or phenomenon under investigation. Thereby, the remote sensing is the process of remotely collect the information about the earth surface features. The remote sensing can be thought of as a reading process to collect the information, to collect the variations of the data. Therefore, the variations, it is not a constant one. The data or information tends to be have been varied with respect to the time. Therefore, the remotely collected data can be of many forms. We have three different forms of collecting the data are variations. The variations with respect to the force distribution. And second one, the acoustic wave. What is acoustic wave? The sound wave generation, sound wave variations. And the most probably used variation is electromagnetic energy variations. Those electromagnetic variations, electric field is perpendicular to the magnetic field variations. Those variation is used right now in the lot of applications. That is like in simply for reading an eyes, for reading an content or data or information or letters to be measured or to be read through our eyes. Thereby, to extract the information with respect to the dark line and with respect to the normal blank, from that the dark line to be readed, those information to be extracted from the eyes tends to be analyzed through the brain. So therefore, electromagnetic energy distribution is a major component, major variations used in the remote sensing process. Therefore, three kind of variations. The first one is force distributions. Where do we use the force distribution? A gravity meter. It is helpful for to measure the variation in force distributions. And second one, the acoustic wave. The acoustic wave are sound wave distributions. The sound wave distributions have been measured in their sonar field, and over the electromagnetic distributions over in the large amount of practical fields. Now let me see a brief description about electromagnetic remote sensing process. How the electromagnetic sensors will be collect the information remotely and how it is to be analyzed and how it is sent back to the users. The first one that will be applicable in airborne, airborne and spaceborne platforms. The most of the countries performing those electromagnetic information through airborne or spaceborne with respect to the defense purposes, and also emits and reflect the electromagnetic energy to provide information about the earth surface features in order to emit and reflect the electromagnetic energy, where electromagnetic energy which is going to operate electric field perpendicular to the magnetic field. The distance is moving, that's why the electromagnetic wavelength. The data are analyzed to provide information about the resources under investigation. So these data to be collect remotely and send back to the and send it to the analyzed those information about the resources under investigation. Now this slide will focus on the basic electromagnetic sensing process. We have two kind of process. One will be the data acquisition and another one is data analysis. The left side, let me see the left side indicates the data acquisition process. The right side indicates the data analysis process. The data acquisition process, to acquire the data, in remotely, to collect information from remotely located areas, phenomenon, or device. So how do we collect the information? This is called airborne, spaceborne, and all. First, this A stands for sources of energy from the sun to reflect satellites, the sources of energy. And second one, propagation through the atmosphere. The electromagnetic energy have been propagated through the atmosphere. And C, Earth surface features within the Earth surface have been collect remotely. And the another category is retransmission through the atmosphere. And the another one is sensing systems. So these categories under the data acquisition process acquire the data remotely from different components. Those energies should be a electromagnetic energy. Those electromagnetic energy is sent back to the sensing products, electromagnetic sensors. What they did for the electromagnetic sensor, either in a pictorial representation or in a digital manner, zeros and binary values, digital zeros and ones, either pictorial or digitized data to be stored, the sensing data to be stored in a digital manner, then it is sent back to the interpretation and data analysis process. The second category is data analysis. The second component of the electromagnetic remote sensing process is data analysis. That how the acquired data is to be analyzed with the help of reference data. The reference data will provide the basic information about the maps, and it will helpful to extract the information, original information. That's why they interpret the data and to analyze the data individually. After that, the information, the last block indicates the information products. Those to compile the information, those information is send it back to the user's request. So therefore, this is the basic process of electromagnetic remote sensing process through Earth surfaces. Now, let me go to the process one by one. The data, first, we have two kind of process as I told earlier. The first one is the data acquisition, where the electromagnetic remote sensing sensors to record the variations. As I told, variation stands for the information, the data. The variation in the way of Earth surface features to reflect and emit the electromagnetic energy, to reflect and emit the electromagnetic energy. And second one, the second process is that the data analysis. So what they exist for the data analysis process, it involves the figure G. That's why the within a bracket G, this involves examining the data, to evaluating the data, whatever we have collected remotely, to examine the data using various viewing and interpretation devices, to analyze pictorial data, or a computer to analyze the digital sensor data, either to analyze the pictorial data or to analyze the digital sensor data through the computer. And what is the role function of reference data? Here, the analyst who can extract the information about the type or extent, location, and the condition of various resources over which the sensors were collected. So this is the basic process behind to the electromagnetic remote sensing process. Now, let me see the radiation principles. So what are the radiation principles? How the electromagnetic energy is radiated with the help of electromagnetic energy. Electric field is perpendicular to the magnetic field over the distance. That's why it is wavelength. The wavelength is lambda, wavelength distance between the successive wave peaks. Let me see that the horizontal line is magnetic field and perpendicular to the electric field E. Magnetic field is represented by em. E and m are perpendicular to the wavelength. The wavelength is passing through the velocity of the speed of velocity of light. What is the velocity of light speed? 3 into 10 power 8 meter per second. Therefore, this V, the wavelength frequency, is the number of cycles per second passing of a fixed point. So what is frequency? Number of cycles per second. Therefore, this figure indicates the how the electromagnetic wave is oriented, and what are the components include a sinusoidal electromagnetic wave, and it is similar to the magnetic field at the right angles. So therefore, both are being perpendicular to the direction of propagation. Now, let me see that the spectral distribution. So, what are the radiation principles behind to spectrals radiation, the spectral distribution of energy radiated from the black bodies of various temperatures? Like, for example, the lowermost 200 Kelvin, 200K, 300K, 500K, 1000K, 2000K, like this up to 600, 6000K. So the x-axis belongs to the wavelength in terms of micrometers, and the y-axis belongs to the spectral radiation extenses, that is m, that is W m power minus 2. Here, the lowermost 300K, the black body radiation curve at the earth temperature, and the 2000 Kelvin black body radiation curve at incandescent lamp temperature, and 400 Kelvin black body radiation curve at the sun's temperature, and 6000 above 6000 K, which indicates the visible radiant energy band. So thank you for listening this video. Keep learning at KS Rangasamy College of Technology, Tiruchengood.